Hello everyone, welcome to a new lecture of Java tutorial. In this lecture, we are going to cover another topic of Java, that is multi-threading. So before that, I just wanted to remind you that I have already uploaded some of the important videos of Java tutorial. If you have not watched it, I have shared the playlist link and also share the document link in the comment section. You can refer from there. So first of all, let us understand what is process. So whenever we are running a program, so that instance is known as process. For example, if you have open an Chrome tab, so if you are executing anything on that Chrome tab, so that is known as a process. And what is thread then? A subset of the process is known as thread. That means if you have opened an Prime video on Chrome tab, right? And if you are running a video, then what happened? That video contains the visual part and also the audio part, right? So visual part and audio part, these are two threads. Then let us say the difference between multitasking and multi-threading. So multitasking means if you have multiple process running, that is coming under the multitasking. And multi-threading means if you have running multiple thread, that is known as multi-threading. So now let us see the advantages of multi-threading. Because of the multi-threading concept, the program execution got faster, right? That's why it does not take more time. And also we can efficiently use the CPU, and also it is suitable for background task. And also it enables parallel execution. So these are the advantages of multi-threading. Now let us see how we can create the thread. So by using the three main approach, we can create the thread by using the thread class, and by using the runnable interface, and by using the lambda. So first of all, let us understand the thread class. Okay, so here I have given an example. Let us run it on the editor to see how it works. So in this example, what I am doing is I have created an class my thread, okay, and I am extending the thread class which is already defined, and inside that thread class I have override the run method, okay. Then I am creating the main class, and inside that main class I am creating the object of my class, and by the object I am calling the start method. Here you can notice that I have override the run method, but I am not directly call that run method. Instead I am calling the start method. So whenever you will call the start method, it will indirectly call the run method, okay. So let us compile and see. Now let us run it. Now we can say it's giving the output as thread running, right? So thread running I have written inside the run method. And the second approach to create the thread is by using the runnable interface. So for that we have to implement the runnable interface, and then inside the main method we have to create the object of thread class, not the object of the myRunnable class, right? So instead we have to pass the myRunnable object to the thread class. Then we have to create the thread class, and by using the thread object we have to call the start method, right? And the next approach to create the thread is by using the lambda, okay. So now let us see the difference between thread and runnable. Thread is a class, but runnable is an interface. But runnable is preferred more in industry level. Now see the next topic, that is thread lifecycle. So first of all, let's understand thread state. So mainly there are 5 states included in the thread lifecycle, like new, runnable, running, blocking or waiting, then terminated. New state tells that the thread has been created, and in runnable state it tells the thread is ready to run. And in the running state it tells the thread is currently running. Then in the blocked or waiting state it tells the thread is wait for the resource. And in terminated state it tells that the thread has successfully completed its execution. So now see the next topic, that is scheduler and context switching. So what is scheduler? So scheduler is a component of JVM and operating system which is responsible for assigning CPU time to the runnable threads. So The next topic is context switching. So what is context switching? So it is an approach by which CPU stops the thread execution so that it can start another thread. So whenever it is going to stop the thread execution, so it saves the current state of that thread so that it can resume later by reloading the current state which has been saved. So next is, let us see some of the method which are used along with the thread. So sleep method is used to tells the thread to pause its execution, and join method is used to tell the thread to wait so that another thread can finish the task first. So yield method, it is used to hint the CPU to switch the execution. So now let us see what is thread priority and thread naming. So thread priority is used to prioritize the thread execution. The thread priority can be set by using 1 to 10, right? The higher will be the priority, the execution will prefer first, but it is not guaranteed. But the thread naming is used to assign a name to the thread. So now let us see what is daemon thread. So daemon thread is a thread which runs in the background, right? So for example, whenever you are going to run a program, the program contains some variable, right? And the variable takes the memory place. So whenever we are going to stop the program execution, so there are some threads like GC is there. GC means garbage collector. So GC thread's purpose is to clear the memory space which has been occupied by the variables. So now let us see the concept of synchronization. What is synchronization? Synchronization is an approach by which we can synchronize the thread access to the resources so that only one thread can access the resource at a time. By this we can synchronize a method of a program. Also we can synchronize a block of code of a program. Now see what is deadlock. Deadlock is a situation when a thread waits forever. So now see the next topic, that is inter-thread communication. So to communicate between the thread, we can have some approach like by using the wait method, by using the notify method, by using the notify all method. So wait method, it tells the thread to pause and release the lock. And here lock means it is a process which ensures that the resource can be accessible by one thread at a time. That means if a thread is accessing a resource, so that thread has been locked that resource so that no other thread can access that. So if another thread has to access that resource, then the current thread which is using that, it has to pause its execution and release the lock so that whenever it will release the lock, so that resource can be used by another thread. So now let us understand the use of notify method. Notify method is used to wake the single thread, but notify all method is used to wake all thread. So next topic is producer and consumer. So producer consumer is an approach whenever one thread is producing an output and that output if will be used by another thread. So that is known as producer and consumer approach. So means one thread is producing something and that output is consumed by another thread. So now understand last topic, that is blocking queue. So what is blocking queue? Blocking queue is a modern approach so by which we don't need to use the wait and notify.